LangGraph's runtime execution model centers on the StateGraph abstraction, which orchestrates node-based computation through directed edges and state transitions. This declarative graph structure enables the composition of discrete processing units that operate on typed state dictionaries, with the Pregel runtime managing the underlying actor-channel coordination. We're about to examine how a simple two-node graph gets constructed, where nodes perform state transformations and edges define execution flow, culminating in compilation to a Pregel instance ready for invocation. The setup will demonstrate node registration, edge connection between processing stages, and the final graph compilation that produces the executable workflow.
From typing import type dict. From LangGraph, constants import start. From LangGraph, graph import StateGraph. Class essay type dict. Topic, SDR. Content, SDR none. Score, float none. Def write essay, essay. Return. Content, FSE about essay topic. Def score essay, essay. Return. Score, 10. Builder equals StateGraph essay. Builder, add node write S. Builder, add node score S. Builder add edge start, write essay. Builder, add edge write essay, score essay. Hash compile the graph. Hash this will return a Pregel instance. Graph equals builder compile.
This code demonstrates how to build a directed acyclic graph using LangGraph's StateGraph API and compile it into a Pregel instance for execution. The pattern follows a declarative graph construction approach, where nodes represent processing functions and edges define the data flow between them. The implementation uses a typed dict to define the state schema essay, with two processing nodes, writeSA and scoreSA, that operate on this state. The graph starts at the special start node, flows to writeSA, then to scoreSA. Each node is a simple function that takes the current state and returns updates to specific fields. When compiled, the StateGraph automatically creates the underlying Pregel application with appropriate channels and nodes, abstracting away the lower-level Pregel API details. This approach provides a cleaner abstraction than directly using Pregel, as it handles channel creation and node wiring automatically. The trade-off is less direct control over channel types and node configuration compared to the lower-level Pregel API. The compiled graph can be inspected to see the automatically generated nodes and channels, which include both the user-defined components and internal management channels. This pattern is particularly useful for workflows where the processing steps have clear dependencies, and the state evolves predictably through each node. Let's break it down.
From typing import typed dict.
Imports typed dict from the typing module, enabling the creation of dictionary types with specific key-value type annotations.
From LangGraph, constants import start.
Imports the start constant from the LangGraph constants module, which provides a predefined value used to identify the starting point in LangGraph's execution flow.
From LangGraph, graph import StateGraph.
Imports the StateGraph class from the LangGraph graph module, providing the foundation for defining stateful graph structures in LangGraph applications. This class enables the creation of graph-based workflows where nodes represent states and edges define transitions, following the Pregel execution model for distributed processing.
Class essay type dict.
Defines a typed dict class named essay that serves as a type annotation for dictionaries with specific string keys and value types. This establishes a structured type hint for dictionary objects that will contain SI-related data, enforcing type safety for the expected keys and their corresponding value types at development time.
Def write essay, essay.
defines a function named writeEssay that takes a single parameter essay with type annotation essay. The function signature indicates it expects an S object as input, but doesn't show any implementation or return type.
Content, essay about essay topic.
Creates a formatted string for the content field by embedding the essay topic from the dictionary variable essay into the template essay about topic. The resulting string will be a complete title like essay about climate change if the topic is climate change.
Def score essay.
Defines a function named scoreEssay that takes a single parameter S of type essay. The function is declared, but its implementation is not shown in this segment.
Score 10.
Assigns the integer value 10 to a key named score in what appears to be a dictionary structure. The line creates or updates an entry where the key is the string score and the associated value is the number 10.
Builder equals StateGraph essay.
Creates a StateGraph instance using the essay class as its state type. The builder variable now holds this graph construction object, which will be used to define nodes and edges for the graph-based workflow.
Builder, add node write S.
Adds the writeEssay function as a node to the LangGraph builder, making it available for execution within the graph structure.
Builder, add node score S.
Adds the scoreEssay function as a node in the LangGraph computation graph. This registers the function as a processing unit that can receive and send messages through channels during graph execution.
Builder at edge start, write essay.
Adds a directed edge from the start node to the writeEssay node in the graph being constructed by the builder. This establishes that the writeEssay node should be executed immediately after the start node in the workflow.
Builder, add edge write essay, score essay.
Adds a directed edge from the writeEssay node to the scoreEssay node in the graph, establishing that the output of the essay writing step will flow to the essay scoring step. This defines the execution order, where scoring depends on the completion of writing.
Graph equals builder compile.
Compiles the graph constructed by the builder into an executable form. The compile method processes the graph definition created through the builder interface and produces a compiled graph object that can be executed by the LangGraph runtime. This step finalizes the graph structure, preparing it for execution where actors and channels will be coordinated according to the Pregel model. The StateGraph abstraction in LangGraph provides a declarative way to construct workflows where nodes perform state transformations and edges define execution flow. This example demonstrates how to build a simple two-node graph where writeEssay generates content and scoreEssay assigns a score, with the start constant marking the entry point. The graph is compiled into a Pregel instance, which handles the underlying actor-channel coordination. The key insight is that StateGraph abstracts away the complexity of directly managing Pregel channels and nodes, offering a cleaner API for defining workflows. The trade-off is reduced control over low-level configuration, but this is often acceptable for workflows with predictable state evolution. The compiled graph automatically creates the necessary channels and nodes, making it easier to focus on the workflow logic rather than the execution details.
The StateGraph writes nothing, scores silence, and hands the void a perfect 10.